okay? And what I'm going to do is while I'm going through it, I'm going to be kind of changing these. I'm not going to write them word for word because I think that's a lot of words to try to fit into these little itty bitty bubbles. So I'll kind of change it along the way, all right? I'm not going to make us write everything down. So when we say tightly packed particles, we can be thinking little space. And what I'm talking about there is little space in between them. So which state of matter has little space in between each of their particles? Solid, I agree. So we're just going to write little space in the solid circle. Okay? By the way, just to make sure we all know what a Venn diagram is. So a Venn diagram, each thing has their own bubble. And then if they overlap, you're saying what do they have in, what do they have similar to each other? Like with the similarity. And if you're going to use the center part, that's what all three of them have in similar. Thank you. I keep saying in similar. You know what I'm saying. Yes. Good job. Thank you. All right. Loosely packed particles. This means large space. So large spacing between the particles. So which one of them has that? Gas. Yep, of course. All right. Then we have medium packed particles. Don't think too hard. Yep, liquid. It's going to be your medium space. I'm just going to put that. Okay. All right. Next one we have is ability to flow. What is the fancy word that we're going to be using to represent ability to flow? Fluid. Good. And who is a fluid? Gas and liquid. Okay, so liquid is the one that we all remember. Gas is one that you're going to have to teach yourself, all right? So gas and liquid have particles that can flow past one another. So we're going to write fluid in that little in-between spot. Okay? All right, your next one says take shape of container. But if you look down, there's also no definite shape. So I'm going to link those up because I feel like they're pretty much the same thing. And I'm going to say indefinite shape. Okay, so indefinite shape. Who has an indefinite shape? Gas is one. Liquid. So we're going to have gas and liquid again. So we're just going to add that right underneath fluid. I'm going to say indefinite shape. Okay, or not a definite shape. Not a fixed shape. You can use any word. All right. Okay, so now I'm going to go right here. Now we have definite shape. Who has a definite shape? There's only one. Who? Solid, exactly. So we're going to put it up with solid. Okay, definite shape for solid. Good. Definite volume. Liquid and solid. I agree. Liquid and solid. They keep their volume. Okay? So I'm going to say definite. So in that in-between spot, you're going to say definite volume. Or fixed volume. Okay? All right. We're not going to worry about no definite shape. We already took care of that. So no definite volume. Who does not have a definite volume? Has to be gas. Yeah. So I'm just going to go scooch this over. And I'm going to say indefinite volume. Okay. All right. And then we have compressible. Compressible. So remember that was a star statement. Compressible. Who's compressible? It is gas. It is gas. It's only gas. Okay, so only gases are compressible. I just want to oh. I'm just kidding, sorry. It was a good beat. It was a good beat. All right. Okay. So compressible, not compressible. Who's not compressible? All the other ones, right? So we'll put it in between solid and liquid. All right. Who contains particles in motion? All of them. Good. So I'm just going to put it right in the center. Particles in motion. Okay. Particles in motion. High kinetic energy. So just so you know, I'm going to be writing high KE. There you go. Not H. I'm going to put high KE and low KE. It's just shorthand for kinetic energy. Okay. All right. So who has the highest kinetic energy, which is your movement? Gases. Yep. So we're going to go ahead and put high KE. Who's going to have the lowest kinetic energy? Solid. So then let's not leave liquid out. What are we going to put for its KE? I think medium. Okay. So you kind of see that it's related to temperature. All right. So your temperature is directly related to the kinetic energy of those particles. So especially later on, we're going to for sure be using them, not interchangeably, but you can kind of use them to represent each other. All right, so kinetic energy and temperature. All right, then the last two are strong attraction forces or weak attraction forces. So what do you picture when I say strong attraction force? This, right? Everybody puts their hands together. Huh? Like a magnet, yeah. So who out of those three do you think has a stronger? Solid, exactly. So we're going to say strong attraction up here. That's how it keeps its shape. And then a gas will have the weak attraction. And if you don't want to leave liquid out, you are more than welcome to write in there medium. I'm not going to because my hand hurts. Okay. Okay. So the last thing that I wanted to add to this was obviously our changes in states of matter, which are all these arrows that are on here. Okay. Because this page right here, this is your notes, right? So liquid to solid, what's that called? A liquid going to a solid. Freezing, good. What is it if I'm going from a solid down to a liquid? Melting, good. Okay. What is a solid down or up to a gas? Sublimation. What is a gas going straight to a solid? Deposition. Thank you. Deposition. All right. And then finally, down here, if we're going from a gas to a liquid, what is that known as? That is condensation. And the opposite of that is going to be, yep, evaporation. Good. All right. Okay. So you have the Venn diagram. This is definitely something that you're going to want to study or be very familiar with what the similarities and the differences are between everything. Okay. So when you're ready, flip your page over